concepts, for example, this demonstrated the resource efficient and on-demand management of services. Then we have named talk. Our idea is to make use of the resource orchestration at the edge of the network, and in this regard, we are making use of the Facebook Wedge. For one goal was the demonstration and presentation at the OCP conference. Motivation and observations that we have made are that we see a tendency of a centralization of cloudification, which the control functionality is moved into the center of the network. We see this on the full end-to-end path between the radio access network technology, the core network, and the application server to radio access network technologies. We see the split of the evolved obedience of 4G network, for example, into a baseband unit and remote radio head, where the baseband unit is also centralized in the network. In the core network, you see the separation of control and data plane of the EPC in the same manner. So all the functionality is aggregated in the center of the network. And another approach that you can witness and recognize at the moment is the deployment of services at the edge of the network. It has, of course, some advantages and disadvantages. Drivers for those concepts are 5G or low latency applications, for example, IoT applications or video caching, or even also telco services like 4G networks that can be deployed at the edge of the network to enable a fast breakout of services, or even security features like anomaly detection or mitigation of the service at the edge of the network. So, drivers and parts that were motivating our work were the availability of the Facebook Wedge, where we see the three-way disintegration of actually the service, the server, the BMC, and the switching silicon, which enables the ability to have a Linux system on top of the Wedge and even deploy services or features on top of the Wedge. We have also made use of other open source software components. I will not go into detail of all of them, but just to name a couple of them, we have been using Docker on top of the Wedge to enable the deployment of specific services. We will go into more details later on. And also Mesos should be mentioned as one of the core elements in the picture for allowing the resource management. Mesos, for those of you who are not familiar with this concept, works with a master and a slave. The slave exposes these sources towards the master, and the master in turn schedules jobs on different Mesos slaves. And another point to should be mentioned is the Calico network, which hooks as a lib network plugin into Docker and allows the ability to provide each Docker container with a single IP address, which also is of relevance of our demonstration that you will see in a later phase. So with that, I would like to hand over to Marcel, who will guide you through the demonstration.
Not sure if I have to take the microphone.
Let me speak a little bit louder. I hope you can hear me. That's a demo setup. So I think we said we want to have a kind of an autonomous rack that can manage itself. That was the goal of the thing. We definitely feel like, as Jules said before, that stuff is happening at the edge, we want to be able to react quickly at the edge without always have to go back to the core and get some approval for some activities. So in that space, we then found the wedge, as said before, and we realized we can run quite a bit of things on that wedge. And what we do here, what we want to show. So on the picture, what you see is on top the wedge. It's big. The other ones are small. In reality, those are beefy servers down there. And this one, the top one, is the little wedge. What we run as core services up there is an orchestrator, which I will show you later on. We run metrics collection, which you always need. We run our own service discovery, DNS, on that, and we keep state. So the idea is that there is state available in each rack that contains network state, service state, and metrics. And that should then allow the rack to manage itself. The state is stored in a distributed database. So the idea is that state would get shared between racks through that state database. What I want to show you on that setup is just a little demo, a little application. It's a DNS services. So the idea is that you have a DNS server outward facing that clients will use to resolve. We want to show you on this one how to scale up and scale down and do some stuff with it. So that is services, those are the core services, and we have the DNS services use case. I think best would be if I just go into the demo and show you stuff. So on top, as you can see, I'm logged into my Facebook wedge. So that's my wedge, little tiny one. I think right now I still have stuff running, so I want to clean up quickly. So from the previous one. So let's see. What we have as core, we have Mesos running. I think I have no idea who knows Mesos. It's a resource manager, so it manages your resources. That's what it does. So we have Mesos running here, and as you can see, the Mesos master running. We have the etcd, that's our state database running, and we have FBOSS running in Ubuntu, so in a container. That's the starting point. If you look at the Mesos itself right now, there's nothing going. All we see are 4 slaves. And if you look at those, you will realize that some have many CPUs, ton of memory, and some have not. And that's the Facebook wedge. So Facebook wedge is part of our bigger picture. And now we are able to deploy software to all of those resources. Very well. To do this, what I have to do is now I will boot up our scheduler. In Mesos land, you need a scheduler that then uses those resources. That's something you implement yourself. You can use Kubernetes, you can use other ones. We implemented our own. So I will now start my core scheduler. What you will see soon is it's connecting Mesos, and you get some resource offers. It will tell you, hey, there's stuff available. What do you need? And those are the offers now from all the hosts. After a while, it's easy to figure out, hey, I need some services, core services, which I have to boot up. So after a while, you should now see that he realizes, hey, there are some services that you need. And they get boot up right now. So it's now starting all those services, and you see it's containers, it goes very, very quickly. One of the ends. Let me go back to the UI, and you will see what we just pulled up. So here you will see that stuff is. So we now got all the services in place. What we have is TCP, that was our data collector. We have a data collector running on each host. Each one has its own data collector. We have database, and we have DNS. I will show you some of them in a little more detail. Like the DNS one. So we just saw the update. So we keep track of all the services in DNS. They should be reachable via DNS mail. And you can see now all the servers are here, the IP addresses, and the one with 11 at the end, that's the wedge. There's also already stuff running on the other nodes. We also had the state database. It's not the nicest UI we use here, but in the state database, we already have, you know how many machines we have? Not all, but all here now. We have networks. That's specific now, the FBOS. So in here, if you go here, you will see that we have 4 10 gig connections to our 4 hosts. So 1, 2, 3, and 4 should be up, which are. And we have some routes already set, some rudimentary routes set in FBOS. That's all done at infra. We also obviously have information about the services down here. So all the services we have, and that's about the service information. So I will show you the influx to be afterwards. Next thing I will do now, get everything running. Sorry, don't forget. We already get numbers, we get the data. So now that's a Netflix board dashboard. It's called Vector. It's talking to PCP from Red Hat. And we already see some numbers here. That's our wedge, 4 CPUs. Obviously, one of my bigger, beefier compute servers. This one will look a little bit different. So here we should see a ton more CPUs. And down here, a lot of the memory. That's this one. Memory is a ton of available memory. So let's now go back and start the application. With everything in place, I will, for the proof, I can now ping like fbos.service.pop. So that's how we resolve this one, and obviously it finds it's all in DNS. So all the servers are reachable. I will now boot up the other scheduler. We have the idea is that you have a scheduler for the rack itself, but each application has its own scheduler. I think it's something we learned is that applications know best how to manage their computer network resources. So we are definitely going for a more vertical approach instead of a network and cloud orchestrator, instead of a horizontal approach with a vertical one. This one is now a subcontroller of the other one. So DNS scheduler, to start up. One thing I want to show you here is we have 2 different types of networks that we use. And our core services, they run bare metal. For our applications, we use a layer 3 kind of type of routing based on Telecom, where it's not overlaid, it's running layer 3. They all get their own IP address. So in that scenario now, the application will boot up the DNS server, and what we should see is that the DNS server now got its own address in its own range. So now going into the DNS host in here, and you probably see now here it is. The new DNS server now is in a different IP range. That's now for the applications. But it's no overlay term. It's layer 3. What's also now done is, obviously, for that, we now need some routes, because they are set on the machine, but they're not set to the outside facing world. So in that context, if I go back to SE, to my state database, you should now see that there is an FBOS, right? That FBOS got an additional route. If you see down here. So here, a W2 route got added. So while the service came up, we got an IP address, and of course we can turn around and immediately tell the switch, hey, that's now the routing information. So it was very easy. I think what it shows is we are very close to hardware. We are very close to all the components, to services, contents, and networks. So we can very quickly react and manage it. Something I haven't showed you yet is we also have a time series database here, in which we already collect data about those services. So again, you have to query that, have to get some queries. I can see, for example, what is my load on my machine. That's now, so Those are my Blade Runner hosts. It's time series, it's stored. Obviously, I can also get information about like the container itself, network, everything is good. Now I'm getting the data from that's from my container, not a lot happening, so that's the kind of how much memory the container needs. We all have it now. So now let's do something. What we do next is we want to put some load onto the system. I will put some more load onto the system. And I will also start scaling algorithms. The scaling component should now recognize we have some more load, we need an additional DNS server, which is kind of obvious. So let's go back to the picture. I'm not putting in data from that one container. I will just look at one of the blocks, EM1. So after, it looks like it's booting up. So it will boot up. It takes a while for it to figure out that stuff is going on. We'll probably show another window. Show this one. You can see what the system is doing underneath. So there's the smart scaling algorithm here. And it's already exciting. So he is collecting using Spark. It's a big data platform. So it's already collecting data and it's already figured out, hey, I should scale up. So it's already scaled up. So you should see now, like in Mesos, there is a second DNS server. And I'm not sure if my charts are already up to date, but they should go down. So now they're going down, and the losses will across those different things. So just a little thing that shows you, by having all the information about the network, having all the information about having all the metrics, having an access to all those components, we can do stuff very easily, very quickly. We have another little thing going on, and that's the thing about efficiency, is that we have a whole rack now, and we only need 3 hosts in there. There's a fourth that's kind of doing nothing. Of course, we don't like this, so there's a little other algorithm going on. We call it the lights off algorithm, a little other one component that we start up. What it will do, it will check we have a minimal amount of services, it's one service. If you have one service, the system will collect, okay, you are doing one period, you have one service, it's 1. Second period, 2. If it increment the counter, and when it reaches 3, it will shut down later. Nothing too fancy, but still, now think about the whole idea. So if you are in our lights off algorithm, start to count, always say, hey, later on here already showed minimal numbers during one period, the second one, the other ones, they're all loaded. So you can pretty soon see that the system shuts down one of the machines. Again, being in the switch itself, it's very simple to manage that because it's a very natural place. So you shut it down, you see some API that we call, and of course the system doesn't like it. You probably see some stuff now, like this one went down, the data collector. You can also see, obviously now, because the switch was there, you could also see that the line went down. So if I go to the state database and check my online, look at this one, you should see that I think it's 4 should be down. So 1 is up, 2 is up, 3 is up, and 4 is down. So just to prove that stuff, it is real time. Obviously now I can quickly move this one up again. I don't want to have it down. 4. And as you've seen before, all we do is we interact with the with the controller via a regular API. We have a simple API, you can talk to the controller through this interface. So that was kind of the demo. I think I was able to show you that we got a lot of information in there that we can use now to make smarter decisions on that rack level. So I think we got the first smart rack here going. And it's also a very fast environment. We've seen the whole pull-up, shutting down, everything goes extremely fast and quick. The slowest one is the machine. So I want to go back to the presentation. And what's next for us? For us, obviously, we want to open source. We will open source our orchestrator. It's a Mesos framework. We definitely want to select and use it other use cases. We have a ton of memory in there. We want to definitely use that. We want to become smarter in that space. We also want to, we got to switch from Kevio. You probably have figured out before that the state about our routing table, it's kind of under our control now. So we don't necessarily need PGP or something to distribute that state. We can selectively distribute that state in those routing tables. In that space, you can become a little bit smarter about your hundreds of thousands of microservices. So in that space, I think having like a chip from Kevium that's a little programmable, we could be a little bit smarter on the data plane with listening to routes and managing routes. So that's something we want to do with that chip from Kevium. We haven't done it yet. We want to include other OCP hardware. Right now, unfortunately, we only have the Wedge running. We want to have a JBOD included and other stuff. There is one question for us is the consistency between racks. How do you manage that state? Is it eventual? Is it static? That's another thing we don't know yet. And of course, we want to use the platform with other parts. Conclusion for us, I think still we feel like the switch is a very natural place for control. It's very, I think it goes against everything else. I think everyone else is now pulling the controller into the cloud. We think the switch is naturally the place where a controller should live or could live, at least one of the controllers. The first thing that gets turned on is the first thing it knows about networking. So, and again, if you think about turning lights off, being able to power down your rack, again, it's a place to be. Other stuff could be put there, could be pixie booting, everything could. There's other stuff you could run on the switch, obviously. There is also, the rack itself seems to become a natural fit for a unity of control we felt like. Especially in an environment as ours, where we have a lot of smaller data centers at the edge. It's not a huge, it's more smaller one. In that space, having unity of control in a rack, it's kind of a natural fit. Again, it's up for discussion. It's just a feeling we have right now. We definitely like Docker and Mesos. The fact that we can now deploy easily the same container on our Facebook switch, the same that we run on the other ones. It's very, very powerful. So there's no question about what OS. We have different OS for different things. We just build that thing and ship it, and it works instantaneously. That's extremely powerful. Mesos, another powerful tool, allows us to really extend the control algorithms. We see a lot of other tools out there that try to control networks and stuff. We feel that that's the hard part. It's really hard. We're seeing it here. It's really hard to control everything timing-wise. That's something you want to do and build yourself. Mesos allows you to build that component yourself. And of course, the one thing if there are any vendors or manufacturer of switches, having a BMC in there is very, very powerful. If you think about the programmable switch, being able to reboot your switch from the outside, it's extremely powerful. So that thing, so if your switch doesn't have a BMC, still works, but too bad. I think there's another feature is that the OS, the regular one, doesn't have to deal with the fans and the other stuff. Question, did you go too far? It's up for discussion. I think that's something we don't know yet. But we definitely gained a valuable insight into the whole thing. I think one last thing, I want to show you the collaborations. We work with many, many companies here. They helped us to get everything running. It was an adventure, I have to tell you. We got the idea a year ago. Open compute hardware, open source software, it's hard. Yes, it's cheap, but the operation of it, it's really hard. So all the people that go for OCP for cheap should instead more think about, no, we have a platform now to build stuff more flexible. We have a chance right now to reinvent how efficient infrastructures are built and managed. That's how I see OCP. So the value is not in the cheaper, no-name box. It's more about there are new ways now how we can manage our network, our infrastructure. And that's something we should use and innovate. And for that, Q&A, I think we are probably at the end of the time.
Yes.
If there are any questions, we are around, so
And
you can grab us every time and we'll answer questions outside of the day.
yeah, we'd love to have questions on the list as well. Thank you very much.